Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is factoring special products. This is a factoring technique that only works in certain situations. One of those situations is the difference of two squares. The most important thing here is the word difference. Okay? If it is not the difference of two squares, but is the sum of two squares, then this will not work. It will only work if it is the difference of two squares. If we notice that it's the difference of two squares, I'm going to make two sets of parentheses. What I will have is the square root of ax. Well, let me make that a little bigger for us. Hold on. Sorry. I'm going to make two sets of parentheses. I will have the square root of ax plus the square root of c and the square root of ax minus the square root of c. Okay? That may not make sense right this second, but it will shortly. So number one, I have x squared minus 4. Is x squared a perfect square? Well, it is x squared, so yes. Is 4 a perfect square? Well, 2 times 2 is 4, so yes, that is also a perfect square. So what I'm going to do is take the square root of x squared and the square root of 4. So the square root of x squared is x. The square root of 4 is 2. X and 2. In one of them it'll be positive, one of them will be negative, and that is all we really have to do right there. All right. On to number 2. I have 4y squared and 25. Jump the gun there a little bit. Is 4 a perfect square? We just learned that from the problem number 1 that 4 is a perfect square. Y squared is a perfect square, and 25 is a perfect square because that is 5 times 5. So I can take the square root of 4y squared. That would get me 2y. The square root of 25 would be 5. It'd be 2y and 5. Remember that 1 needs to be positive, 1 needs to be negative, and we are good. On to number 3. Is 9z squared a perfect square? Yes, it is, because the square root of 9 is 3. Z squared is, again, just z squared. 64, the square root of that is 8. So I can take the square root of 9z squared and the square root of 64. That would get me 3z and 8. 3z and 8. 1 would be positive, 1 would be negative. Remember what I said about this only works if it is the difference of two squares. All right, on to number 4. X squared is a perfect square. 16 is a perfect square. However, this is the sum of two squares. Like I said a little bit ago, this only works, our process only works if it is the difference of two squares. Because it is the sum of two squares, it is not factorable. There's nothing more I can do with that expression. Therefore, I can just write not factorable or already factored if you would like. That would work as well. On to number 5. Is 2 a perfect square? Go ahead and type in the square root of 2 in your calculator. See what you come up with. Once you do it, you're going to notice that the square root of 2 is 1 point something, I believe. Okay? So that is not a perfect square. So I need to look here. What is the first step in factoring always? It's to look for a GCF. Are 2 and 8 divisible by the same number? Yes, they are. So my GCF in this case would be 2. Can pull out the 2. That will leave me with x squared minus 4. All that is equal to 0. Now that inside the parentheses, I have the difference of two squares because x squared is a perfect square, 4 is a perfect square. So I can write that as x plus 2 and x minus 2. All that would be equal to 0. From here, I can use the zero product property. So 2 would be equal to 0. X plus 2 is equal to 0, and x minus 2 is equal to 0. Well, 2 is not equal to 0, so I can get rid of that. I can subtract 2 from both sides, so x could be equal to negative 2. I can add 2 to both sides, so x could be equal to positive 2. And we're good. Moving on to number 6. Is 49y squared a perfect square? Well, we know y squared is. 49 is in fact a perfect square because it's 7 times 7 will get me 49, or the square root of 49 would get me 7. So I can take the square root of 49y squared. 81 is also a perfect square. It's 9 times 9, or the square root of 81 would be 9. So from here I can write this as 7y plus 9 is times 7y minus 9, all that would be equal to 0. Use the zero product property. I need to subtract 9, so I'd have 7y is equal to negative 9. Divide by 7, and y would equal negative 9 over 7. Okay? Here I'm going to add 9. 7y equals 9. Divide by 7. Divide by 7. And y would equal positive 9 over 7. There we are. On to our next section. The next section is the perfect square trinomials. This is the factored form of a perfect square trinomial is a factored square. What I'm looking for here is, do I have a perfect square at the beginning and a perfect square at the end? If I do, it should work out correctly. All right? So, the other thing that we need to look at is at the back end, my C value always has to be positive for this to work, because that way my signs, when I factor it, will all be the same sign. What we're going to do here, just like I showed you a minute ago, is I would take the square root of ax, and it would be whatever sign my b value is. So in this case, it would be plus the square root of my c, square root of ax, plus the square root of my c. Okay? So on to problem number 7. X squared is a perfect square, 9 is a perfect square, so I can take the square root of x, the square root of 9. That would get me x plus 9 because my b value is positive, times x plus 9. I can rewrite that as x plus 3 squared. I think I said that as x plus 9. It's really x plus 3 times x plus 3 because I needed to take the square root of 9. On to number 8. Is y squared a perfect square? Yes, it is. Is 16 a perfect square? Yes, it is. It would be 4 times 4. So from here, I'm going to take the square root of y squared, the square root of 16. My signs in this case will be negative because my b value is negative. So it would be y minus 4 times y minus 4. I can rewrite that as y minus 4 squared. On to number 9. Is 4 a perfect square? Yes, it is. Is z squared a perfect square? Yes, it is. If I take the square root of 4z squared, that would get me to z. Is 1 a perfect square? If you type the square root of 1 into your calculator, it should come out to 1, so 1 is in fact a perfect square. Remember, my sign is going to be whatever my sign for my b value is. So it'd be 2z minus 1 times 2z minus 1. Now on to 10. This is set equal to 0, so that means I need to solve it. All right? The first step is to check and see if I have a GCF. In this case, I will not have a GCF. The second step would be to see, is 25x squared a perfect square? It is. The square root of that would be 5x. Is 1 a perfect square? Yes, it is. The square root of that would be 1. My sign is positive, so it would be 5x plus 1 times 5x plus 1 is equal to 0. I can rewrite that as 5x plus 1 squared is equal to 0. Now I want to start solving for my x value. So I would take the square root of 5x plus 1 squared and the square root of 0. That would get me 5x plus 1. Because anytime I have the square root sign and a squared sign, they just cancel. The square root of 0 is 0. Subtract 1, subtract 1. 5x would equal negative 1. Divide by 5, divide by 5. X would equal negative 1 over 5. Okay? On to number 11. Again, I would check for my GCF. 9, 30, and 25 do not share a factor, so that will not work. I do want to check and see if 9y squared and 25 are perfect squares. They are. The square root of 9 would be 3. Square root of y squared would be y. The square root of 25 would be 5. My b value is negative, so this would get me 3y minus 5 times 3y minus 5 is equal to 0. Can rewrite that as 3y minus 5 squared is equal to 0. Again, I'm going to start solving for y, so I need to take the square root. Gets rid of my squareds. This is 3y minus 5 is equal to 0. add 5, 3y is equal to 5, divide by 3, y is equal to 5 over 3. All right, let's go ahead and move on to the back. We're going to mix it up here. So I'm going to have some that are perfect squares, difference of two squares, some that are will be the perfect square trinomials, and we need to make sure that we're looking for GCFs, and maybe we'll have to just factor it straight up. We'll have to see. Number 12, do I have a GCF between x squared and 16? I do not, but is x squared a perfect square? Yes, it is. Is 16 a perfect square? Yes, it is. So I can take the square root of x squared, the square root is 16. This would be x plus 4 times x minus 4, which would equal 0. Use the zero product property. Subtract 4, this would be x equals negative 4. I have x minus 4 is equal to 0. I can add 4. So x would be equal to positive. You don't need the positive sign there. Would be equal to positive 4. All right. On to number 13. I have 3x squared minus 27. The first step is to always look for a GCF. Well, 3 and 27 are both divisible by 3. So in this case, my GCF would be 3. If I pull a 3 out, I end up with x squared minus 9 is equal to 0. I do have a difference, so let's go ahead and check and see if I have the difference of two squareds. Is x squared a perfect square? Yes, it is. Is 9 a perfect square? Yes, it is. Well, x squared, the square root of x squared would be x. The square root of 9 would be 3. So this would be 3 times x plus 3 times x minus 3. All that would be equal to 0. Set everything equal to 0. Does 3 equal 0? No, it doesn't. I can subtract this 3, so x would equal negative 3. Moving on to the last one, I can add 3, so x would equal positive 3 as well. All right. Moving on to number 14. The first thing I want to look for is a GCF. Is there a factor of 16, 24, and 9 that they all share? There is not. The next thing I want to look at is, because I have a positive or my C value is positive, I want to see if I have a perfect square trinomial. Is 16x squared a perfect square? Yes, it is. The square root of that would be 4x. Is 9 a perfect square? Yes, it is. The square root of that would be 3. I'm going to use negative because my b value is negative. So it would be 4x minus 3 times 4x minus 3, which equals 0. I can rewrite that as 4x minus 3 squared equals 0. To get rid of the squared, I would square root both sides. So 4x minus 3 would equal 0. Add 3, 4x would equal 3. Divide by 4, x equals 3 over 4. Solving for the x after we have factored it should really just be review for you from Algebra 1. Hopefully you know how to solve for the x value. If not, please come in and I can help you with that. All right. On to number 15. Again, the first thing I always want to look for is, do I have a GCF? Well, 3, 36, and 108 are all divisible by 3. So if I take out a GCF of 3, I end up with y squared plus 12y plus 36. From here, I want to see if I have perfect squares in my a and c values. Well, y squared is a perfect square. The square root of that is y. Square root of 36 is 6, so I do have perfect squares. The b value is positive, so this would be y plus 6 times y plus 6 is equal to 0. I can rewrite this as 3 times y plus 6 squared is equal to 0. From here, I want to set them equal to 0. So 3 would equal 0, which it does not, so I can get rid of it. Y plus 6 squared would be equal to 0. I can take the square root to get rid of my squared and my square root. Take the square root of 0, so y plus 6 would equal 0. Subtract 6, and y equals negative 6. that is the end of our lesson. The most important things here to remember are, again, always to be looking for a GCF. How to do the difference of two squares. If I have a binomial and it is the difference, I can check and see if my my A value is a perfect square. If it is, and my C value is a perfect square, then I can use my process for the difference of two squares. You got to make sure that it is the difference of two squares, though. It cannot be the sum. Also, for perfect square trinomials, remember that if your A value is a perfect square and your C value is a perfect square, then I can use our process for the perfect square trinomials. Remember, if you have any questions over any of this, you need to come in and see me or ask at the beginning of class. Thank you for watching the video, and have a great day.